know that to that question that you think there are more or less M&Ms in this bowl than there are Skittles in this bowl, you've actually answered the way a 5 or 6-year-old would answer. You have failed the task of conservation. This is difficult, and I'll let you know that studies have shown that about 60% of people get this question wrong. They fail to use formal operations, so do not feel bad if you have answered incorrectly. You can actually test this for yourself. Take a piece of paper and imagine that if in my scoop here, my second scoop after I've mixed up my M&Ms and Skittles, if in my scoop I have all Skittles, 15, and I put it in that bowl, we have the same, right? That's very easy to see. 15 M&Ms are now in my bowl with Skittles, and we have 15 Skittles in my bowl of M&Ms. But what happens if we have an M&M mixed in with my second scoop? So now I have 14 Skittles in this scoop and 1 M&M, and I put it in there. Because I'm not adding or subtracting, and I'm always just changing the same number of candies in each scoop, it actually stays the same. I have 14 M&Ms now in my Skittle bowl, and I have 14 Skittles in my M&Ms bowl. This is the same if I got 5 M&Ms in my scoop and had 10 Skittles here. We would be left with 10 M&Ms in my Skittles bowl and 10 Skittles in my M&Ms bowl. Right? The number doesn't change. Our conservation remains the same. To do this, you have to think about that principle of irreversibility. Young kids don't do that, right? They just rely on that final centration, that physical property that they see. If we think about the height of the water differences in the glasses, that's how young kids come to their conclusion. You might have overcomplicated it by starting to think about probabilities and statistics, but remember, we're not changing any properties. Everything is maintaining the same, and we're conserving the same number.